Good evening, everyone. Welcome to our March webinar. The theme for tonight is A-star rated homes. As we come into winter, high-performance thermal design is especially important. It shocks me that Australia's housing stock is so poorly designed that more people die of cold in winter in Australia than in Sweden. Fortunately, that's improving. Our two speakers will talk about recent advancements in housing design that could bump up the average energy rating of houses to A stars. I am Sandy Su, Secretary of Renew Sydney Central Branch. Usually we have physical meetings, which we have been videoing and posting online. Welcome to you all if you're signing in locally from the Sydney region, elsewhere in Australia, or maybe even from overseas. It is exciting to be engaged with so many people here tonight. Firstly, I want to acknowledge the traditional owner of the land upon which the Sydney Central Branch operates from and where I am at the moment, the Cadigal clan of the Eora Nation. We acknowledge their leaders, past, present, and emerging. We also acknowledge their sustainable stewardship of the country over many years. I would also like to acknowledge the traditional leaders of their parts of the country or in the other lands wherever you may be joining us from tonight. The recording of our last event is also available online. I'll post a link later in the chat box. Tonight, as I mentioned before, the theme is the A-star rated houses. We have the pleasure of welcoming two speakers, McLeod and Graham Hunt, our old friend. I will introduce them shortly. If you have technical issues during the evening, please use the chat function and get assistance. You can ask questions using the Q&A button. We will go through some questions at the end of each presentation. It is normal that we get more questions than we will have time for, so please be patient. And we might be able to email to you for your questions later tonight if we couldn't answer your question. For the questions, I will be assisted by Marisa, the co-convener of Sydney Central Branch. We will be recording the whole presentation tonight, and it should be available on our YouTube channel in the next few days. So without further ado, our first speaker for tonight is McLeod. Rob is Renew's Sustainable House Advocate. You might have heard of his name. He leads work on Renew Climate Resilience Homes campaign. Rob joined Renew in 2019. Previously, he has worked in housing and climate issues as a policy advisor, campaigner, and case worker. Well, let's welcome Rob. Over to you, Rob.
Thank you very much, Sandy, and thank you very much to the Renew Sydney branch for organising tonight's event. Very, very pleased to speak and to discuss these issues with you all. My name is Rob. I'm joining from Wurundjeri country, Melbourne. I will share my screen, so bear with me for 1 second. So tonight, Graham will be speaking about the process of designing 8-star homes and what individuals and communities can be doing right now. But we also wanted to take this opportunity to talk about a campaign that's been very, very important to Renew, and I think is a very important issue that we need to be working on, and that's lifting the energy standards for new homes through public policy and through the national minimum standards for new homes. We're in a very important moment right now throughout 2021, and there's real scope to change the rules and change the standards in the code that will actually have the opportunity to lift up how new homes are built around Australia. And this is something that is very near and dear to Renew's heart, as I know it is to many of you joining tonight. So there's a lot of places that we can get into this issue, and a lot of places to start. But I think one thing that really does focus the mind is to start here. This is the 4th of January 2020, temperature map of Australia on that day. This was within a multi-day heat wave that I think a lot of us have experienced, and a lot of us have very profound memories of. In Sydney, the temperatures were high and have been high at various times around then. In parts of Western Sydney, temperatures on the days around then, at least, were recorded as high as the high 40s. I think 48 was the highest that it got to. This is a climate emergency that we're in. This is something that we need to take action on now. We need to take action in a lot of different ways and in a lot of different facets of Australian life and internationally as well. But one of the really central ones is our housing. Housing is a particularly core issue because it covers both, in the lingo we say adaptation and mitigation. It covers both how resilient we are and how safe we are in a changing climate like this, and in a climate where we do have extreme weather like this. It also affects how much greenhouse gases we're emitting and how we contribute to actually avoiding the worst outcomes of runaway climate change that is a near and present threat for us. There are so many different things that we can be doing around housing, but we know that improving the standard of our homes and having better energy performance in homes is just a win-win-win. There's so many good things about it. It means that our homes are healthier. It means that we're safer in those extreme weather events. And, you know, I've just posted a picture of the height of summer in a heat wave, and Sandy's absolutely right in the introduction that winter is actually, you know, a time when we're in our homes a lot, and when homes aren't warm and aren't comfortable, there are actually massive health impacts of that. So it's not just one aspect of health, but it means that our homes are more comfortable. It lowers our energy bills, often substantially, and it lowers greenhouse gas emissions as well by using less energy or changing the ways that we produce that energy. And that can reduce pressure on the grid at peak times, which perhaps is maybe a less exciting thing for a lot of people around the country to notice, but it's actually a really crucial thing in how we build and maintain our infrastructure. Tonight we'll be talking, and Graham will be getting more deeply into the question of 8-star homes and what that can look like and how we can actually do that. But it's worth just putting in context what that can mean. So NaTHERS, the NaTHERS ratings for homes is done according to different values across a lot of different regions and climate zones in Australia, and measures the energy loads that are required for heating and cooling in a given home. You'll see that though the energy required in different regions actually varies because of climate zones, and because, for example, in Darwin here on the left, people are using a lot of energy to cool their homes to keep them comfortable. Whereas in Brisbane, that's a very different picture. You'll notice, interestingly, the difference between Eastern and Western Sydney, because of the differences of climate there. And actually, to attain a 6 or a 7 or an 8-star home or any given rating, you're actually using more energy than in Eastern Sydney on the seaboard. You'll also notice here, I'm not sure how visible it is on the screen, but the difference between different ratings can be quite stark, but it's not just a 1-to-1 star rating. So the difference between 0 and 1 stars is not the same as the difference between 9 and 10 stars, just in pure energy terms. But when you're looking at an increase from 6 to 7 stars, which is a key increase that we're thinking about at the moment, that's in most places around about a 25% reduction in the energy required to heat and cool a home. So between 18 and 28%, depending on which part of the country you're in. That saves money. If you're going from, again, let's say a 6 to 7 star home, you're actually potentially saving a substantial amount of money on your bills each year. This is some Renew modelling that was done in the context of Victorian medium-sized homes, and varies from place to place, but gives you a flavour of what that can be. Potentially several $100s can be saved per year through thermal efficiency improvements, as do all electric homes. Consistently, and this stands to reason, the homes with the lowest energy bills are going to be the homes with a high thermal efficiency rating that are all electric and have solar panels that is generating the energy that is used in that all electric home. So homes where you don't have to pay a gas connection, homes where you're not paying a gas bill, and where you're using relatively little energy that's generated from your rooftop, you're laughing. That's going to be the cheapest bills, and that goes across a wide range of areas. The thing is, all of that is really, really clear that it is just a win-win-win. Improving the energy performance of your home makes sense under pretty much all conditions, but we know that public policy mechanisms are actually needed to make sure that that benefit is enjoyed by the majority of people in Australia. At the moment, about 10% of homes in Australia are built to a standard that's at least a star above the minimum standard. That is to say, only 90% of homes just build to the minimum standard required by law, and 90% of houses, I should say, and nearly 70% of apartments are just built to within a star of the bare minimum standard. So the National Construction Code is the policy mechanism essentially that sets what that minimum standard is, and it's currently rated at 6 stars, NaTHERS, but that's updated every 3 years, and it's due for an update coming into effect in 2022. The minimum standards for energy efficiency have only really been in place in various guises. We can get into the history, but essentially only in place for less than 20 years, and they haven't been upgraded from the 6-star standard in the code since 2010, which is just falling behind in the context of the climate emergencies that we're in and the technical capacity that we've got to improve the standard of homes. That's just falling way beyond what's needed and what's possible. So the update of the National Construction Code is underway at the moment. Renew has been in a central leadership position of a community campaign that has been pushing for a long, long time for improvements in the code that will lift the minimum standard from 6 stars up well above 7 stars. And that's been a campaign that's been running for a number of years, that's brought together a coalition of over 60 community and tenancy and environmental groups to push for this sort of change. And it's looking like, and we have had some really big wins through that sort of pressure that's come from a lot of different places, including that campaign, but including people in the industry as well and other people who are supporting change. The government has given direction to the Australian Building Codes Board to develop a new draft code that will be released for public consultation pretty soon, over the next perhaps 3 months. And Renew is on the technical working group for this code development, which is the first time that a community consumer representative has been involved in this process. So what can we expect to come out when this public consultation on the draft code comes about? There's a few things. There has been direction from the nation's energy ministers to the ABCB, Australian Building Codes Board, to model to develop draft code for 7-star ratings as a minimum, so going up from 6 to 7. That's definitely a significant step forward. We have pushed for a long time for it to be even higher than that. We think that our analysis has shown pretty consistently that there's value for money in raising it beyond that to at least 7.5 stars and up to 8 stars. But 7 stars is still a significant improvement on 6 stars, of course. There are some other things which perhaps aren't as much of a headline-grabbing news, but actually are really quite important and have a potential to change how homes are designed and how homes are approved through the code. A big one of those is that for the first time, it looks like the code will include a home energy budget. So actually developing a new tool that's an addendum or I guess you'd say an evolution of the NaTHERS system to include not just the thermal shell, but also fixed appliances like heating and cooling, lighting, hot water and pool pumps. And actually develop by including all of those things in one rating tool, a home energy budget that can then crucially be weighed up against the renewable energy that you're generating in the home. And we'll get into what that means concretely in just a second. It also is committed to fuel neutrality, i.e. it's not favouring either gas or electricity, or for that matter, renewable electricity. And that's something, again, I might just get back to in just a second, because that potentially has a big bearing. So the direction to the Australian Building Codes Board from the nation's energy ministers through what used to be COAG was to develop two options. The first of them are provisions that achieve a level of thermal comfort equivalent to 7 stars, NaTHERS, and a net zero annual energy use for regulated building services. So what that would mean is that for all of the energy that you're using at home through the main appliances, you would have to produce that much energy through renewables, and that will generally be solar PV on the roof, with some very rare exceptions. The second option is a less ambitious option that would still have the same framework in place with a maximum energy use budget that can be compared to the solar on your roof or other renewable energy, but wouldn't require it to actually be net zero. So wouldn't require you to generate as much power from renewables as you use in the home, which is pointing still in a similar pathway, but is less ambitious in terms of renewable energy generation. Just coming back to that, we think that a really key issue that needs to be addressed in homes and in housing over a very short period of time is the future of gas, because we know that we need to transition away from fossil fuels very much, including gas, and residential is actually quite a significant part of gas use. So getting off that means building our homes in a different way and stopping those connections to gas. This will not do that, and I think that there should be more things in place to do that, and we're seeing leadership not through the code, but instead through local governments or through regions such as the ACT. That said, we know that it is worth noting, particularly for people who are building their own home or trying to comply with this code, it's really worth noting that if we are moving to a scenario of net zero annual energy use, you're always going to get better bang for your buck by building all electric homes, and by having all electric homes that don't require a gas connection, where the energy that you're generating from the roof by the code is actually being used in your home. You're always going to get the best bang for your buck. So that's going to be a really key issue in all of this process. I'm pretty conscious of time, because the main part of tonight will be Graham talking through 8-star homes, but I would just like to say briefly what happens next. The public consultation is happening in mid-2021, so all of this will be public and open to look at over the next 2 or 3 months, perhaps May or June. Final decisions, after that consultation, it'll go back basically to politicians, to the ministers, who of each state and territory and Commonwealth, who will make final decisions, and those will be announced in early 2022. The code comes into effect in September 2022. This is a pictorial description of what I've just said, but by and large, the key thing is that everything will be finalised by early 2022. And in fact, there have been some delays from that particular graphic. This isn't the only thing that we're pushing for when it comes to the Climate Resilient Homes campaign. Raising the new home standards up to seven or more stars is critical, and that's a really, really important response to making our homes climate resilient. But there's a bunch of other things as well, particularly that affect existing homes, which on average perform worse than the newer homes that are being built. And that means that we need to be investing in home retrofit programs. It means we need standards for renters. We need better consumer information, universal consumer information that anyone buying or leasing a home can access, energy ratings. We need a rapid transition to all electric homes powered by renewables. And the way that we're going to get there is through community-led sustainable design that's feeding into these government policy mechanisms. None of this would be happening if it weren't for the people in their own homes or at the grassroots level who are designing their own homes in a sustainable way and showing what's possible, and therefore leading the way for this sort of government change that we're looking at. To make it happen, there's still work to do. The decision will come in the second half of this year or early next year. And this should have happened 3 years ago, a rise to 7 stars, and there was a very good case then. There's still a very good case now. But to make sure that it does happen, we need to keep the pressure up, and we need to make sure that the decision makers are actually hearing about it. So if you're watching this and wanting to find out more information, make sure that you're subscribed to Renew and Sanctuary or a Renew member, because you'll get information that way, including through email and in the magazines. You can absolutely make a submission to the public consultation that's happening between May and July this year, and I would absolutely encourage you to do that. We will be sending out details about that. And there may also be other things that we need to do in the second half of this year to make sure that those decision makers are hearing that there is public support for this, because the only reason that this won't happen, it's not because of the numbers, it's not because of the cost benefit analysis, because it absolutely makes sense to do this. The only reason this wouldn't happen is if decision makers are hearing more from the people who oppose change to those who actually support it. So there will be things that need to be done. On that note, I'm worried that I've already gone over time, so I'll leave it there. But thank you so much once again to the branch and to everyone watching now.
Thank you. Thanks a lot. Thanks, Rob. Let's hope that the construction code will get upgraded really soon. We also have noticed there are some questions coming in, and we have decided we will answer the questions after Graham's speech. And I can see that some of the questions probably will be answered in Graham's talk later on. So without further ado, let's welcome Graham. Graham is a director of Delisle Huntwood Architects, who specialize in sustainable design. He has over 35 years of experience as an architect and over 20 years of experience as a NaTHERS assessor. He designed and built his first passive solar homes in the early 80s. He currently represents the Australian Institute of Architects on the NaTHERS Technical Advisory Committee and Stakeholder Consultative Group, as well as the Australian Building Codes Board Residential Energy Efficiency Working Group. And Graham is also our co-convener in the Sydney Central branch. And you might know him really well. Let's welcome Graham. Graham, the stage is yours.
Thank you, Sandy. Okay, I hope everyone can see my slides there. And thanks to Rob for giving that introduction to the Renew Climate Resilient Housing campaign. As he said, the next 12 months is going to be critical in terms of getting movement with the regulation. So I'm going to be talking about what an 8-star house looks like, because we have to keep in mind if the bar is raised to 7-star, that's still the minimum legal requirement. It doesn't necessarily mean it's actually where we want to be. So what does a 8-star house look like? This is what it doesn't look like. This is a famous modernist design, probably nearly 100 years old now, designed by Mies van der Rohe, developed a reputation for performing very poorly thermally, and that's because of it's just too much glass, very lightweight structure in a cold climate. So unfortunately, in a lot of areas, we still have a fascination with using a lot of glass. Following on from what Rob introduced, I'll just give a bit more background about the reason for wanting to increase the stringency to 7 stars and beyond. One thing to keep in mind is we design a house now, it's going to be last and be used over the next 50 to 100 years. And we know that the climate is changing. And so where it will be over that time frame is anyone's guess, but it's going to become more extreme. There's been a study done, there's a reference there at the bottom, that's showed that a high-performing house built at this time is likely to perform like a standard 5 or 6 star house by the time we get to 2050. So we need to make them as efficient as possible. Rob's covered the additional requirement of not just the thermal shell, but also the likelihood of being adopted in the National Construction Code, the requirement for the energy budget, and hopefully with the aim to achieve a net zero energy rating for new housing. Some people say, well, does it really matter? Solar panels have become very cheap, very affordable and accessible. Can't I just put on more solar panels and that will cover my emissions? There are a few more things to do that sort of outweigh that. And one is that a built form is hard to change. We can always add more solar panels, or in another 20 or 30 years, there may be a totally new technology that generates energy, and it may not be on our roof. We might have distributed grids, but we all know the cost of renovation. If we don't get the form and the thermal envelope of our houses correct now, it always costs a lot of money later, and it's difficult to retrofit, to add things like insulation. As Sandy mentioned, health impacts from poor thermally performing buildings in this country are quite significant, and I'll discuss that a little bit further. For designers and builders who are listening, building and designing an energy efficient home can give you a marketing edge. People are aware of the high cost of energy over time, and they're keen to find better performing homes. Now, in terms of future climate, the NaTHERS tool works on an average climate file for different locations in Australia. I think there's 64 different climate zones. We've already had a question earlier tonight about the climate data being out of date, and that is true. It is being updated, and hopefully it will be updated on a more regular basis. But CSIRO have developed a tool where you can go into this website and you can find out what climate zones your particular climate zone will be like in 20 years, 50 years, etc. So for Sydney area, if you go onto that website, it'll tell you in 30 years, our climate here is going to be more like Byron Bay and perhaps more like Brisbane. Western Sydney is probably going to be more like inland Queensland. And so we can use that as a tool to, when we model in NaTHERS, to just see not only how the house might perform now, but how it might perform in the future. As Sandy mentioned, deaths from excessive heat and cold are significant in this country. Rob mentioned the heat wave recently in January. One news snippet from that day was the ambulances were as busy as they were on a normal New Year's Eve. And there's been a fair bit of research in this, and there's several articles, but you can see that reference to we're not performing as well as Sweden. And that's because they pay a lot more attention to the thermal design of their buildings. Earlier this year, the AMA declared climate change a health emergency. So there is a driver there that we need to be raising the standard of all of our housings. There is a report that underlies, initially was done several years ago, that drove a lot of this work. And I've just put that there as a reference. I might be able to drop some of these into the chat box later. This chart sort of breaks down on average what the spread of energy use is within the household. And you can see the significant input of heating and cooling. So if we do want to get our energy use down and get to a net zero energy target, that's certainly the first place to head. And by having a thermally efficient house, you can reduce that significantly. So what does make an 8-star house? Good, sensible design. There's been a few questions I've noticed in the Q&A box about what about the extra cost of a 7 or an 8-star house? A lot of our existing houses could be easily raised from a 6 to a 7 or 8-star level just by doing better design. It doesn't mean we have to buy more expensive materials, or, you know, that helps, but we can do a lot just by getting the form of the building right, getting the window arrangement correct. And so to design effectively, there's certain things we need to consider. The first one is the actual location, the particular climate, and the site in terms of, are you overshadowed? Where do the breezes come from? And that sort of micro data. The actual plan form can help a lot in terms of getting a good rating. An efficient shape means there's less interaction between the interior and the exterior. There's less surfaces where you can lose or gain heat. The glazing is important. And this might be one area where you might need to spend a bit more money. But the issue is, in terms of spending a bit more money, it's the savings you make over that 50 to 100 year life frame of the building in terms of reduced energy consumption. Insulation is also important, and it's getting it to the optimum level. And that's where working with your NaTHERS assessor is where you can optimize that. Thermal mass can be important. Not in all climate zones. Tropical climates don't need it as much. And it's getting the right amount of thermal mass, not having too much, because then you're going to need a lot of extra energy to heat the home. And it's also placing it so it's not exposed to the sun when it doesn't need to be. Ventilation is important for cooling, as is shading. So we'll go through these in more detail, but also working with your NaTHERS assessor is important in terms of getting a good rating. Unfortunately, a lot of the time, assessor is brought in at the last minute just to provide certification and confirm we get to that minimum 6-star level. Assessors can do a lot more than that, and they can help you optimize and refine your design. So it is important that you get engaged with them. Even if you're a building client, you're not necessarily a designer or a builder, ask to speak to your assessor and talk to them about what they're going to do for you, and I'll provide more detail as to how you can engage with them closer. I'm just dropped in here a very good resource, yourhome.gov.au. It's a federal government initiative. There's a new edition about to come out, and there's a lot of very good, useful information, not just about good thermal design, but about sustainable design in general. So some examples of 8-star homes. Well, in principle, sort of. A termite mound. I guess we need to look at, what does nature do to cope with climate? Termite mounds are usually built so that they're naturally air conditioned, so the air can rise up through the turrets and exhaust and draw cooler air from lower down. This is a picture of a mass weaver's nest from South Africa, where the birds can create the ideal temperatures for their chicks to hatch in by building using natural materials and closing them together, minimizing the exposure. And often traditional building methods and techniques can help inform what we should do in different particular climates. We've also forgotten a lot about what good thermal design is. This is a plan Colonel Light developed for Adelaide, and it was laid out on very good solar design principles. Unfortunately, a lot of newer subdivisions are not laid out on this basis. The trajectory for low energy homes, which has driven the requirement or the campaign to raise the thermal rating to 7 stars, looked at a whole lot of things, but it didn't look at precinct design, about subdivision design, about suburb design. It was stated early in the process that was out of scope. I think the trajectory is meant to be an ongoing process so that we can keep evaluating how our housing is performing and, if necessary, again, raise the standards. I think we need to push heavily that in the next round of the trajectory, precinct and subdivision design is very important, because if we get that right, it's much easier to design thermally efficient homes. Here's another example of traditional building that works very cleverly with the climate. It's a cliff dwelling from Colorado, where the houses are built in the lee of a south-facing, in the northern hemisphere, a south-facing cliff. So they get shaded totally in summer, and they get all that nice low-angle winter sun coming in, heating all the thermal mass of all that adobe. It's not rocket science, this type of thing, and we as a species have known how to do it for a long time. Even the humble Queenslander was developed to work with the local climate because of the humidity, to allow for ventilation around. We seem to have forgotten in our suburban developments about verandas and other techniques to utilize natural ventilation. So just going through the principles we need to consider. Site and location is important, and the orientation of the site is very important. We need to try and optimize our orientation to the north. That can be difficult at times with our block arrangement. We may have a block that's facing east and west, and we may have to use some clever ideas in order to overcome that. Overshadowing from adjoining buildings, especially larger buildings or big trees, can impact on our solar performance. The local climate obviously has an impact, and the strategies we use in the tropics will be totally different than strategies you'd use in say, Tasmania. So the climate zone within the local NaTHERS setting, but also what your local situation is, or what the microclimate is. If you're not familiar with that, maybe talk to older locals as to, they've been there a while. They can tell you a bit about, the direction of prevalent winds and how hot it can really get in summers, etc. The topography is also important in terms of keeping the cost of construction affordable, but also working with the slope of the land. And what is also becoming more important is in rural areas, well, also on the fringes of the cities, is designing for bushfire. And this should work in hand with your thermal envelope design. There are restrictions depending on your BAL, your bushfire rating, on what type of windows and how you seal your roofs and other details. So it's important that they can be considered at the same time. This is just a typical site analysis diagram that architects would use at the beginning of a design process to consider all of these items. I did mention that plan and form is important, trying to keep the shape plan form as efficient as possible with minimal articulation. If you have a plan form that steps in and out and has lots of exposed walls, it's much harder to get an efficient rating. You should try and keep the plan form narrow to allow for ease of cross ventilation through most of the rooms. You should try and optimize the northern orientation where possible, because with quite simple eaves and shading devices, if we can get most of our glazing facing north, we can optimize the amount of winter sun coming in, but easily exclude most of the summer sun. Our more habitable spaces should be on the northern side, and we can put services such as bathrooms, garages to the south or to the west. Here's just a simple plan form that shows north is up the page. So the early morning winter sun comes from the right-hand side. We have bedrooms to collect that. We have a courtyard, which acts as a bit of a sun trap, and the main living room opens onto that. But on the eastern side, we have a patio, which provides screening from the early morning summer sun. And on this side, we have a carport, which provides screening from the afternoon summer sun. And then we have services on this side as well, which aren't getting any direct sun and so not important. This is an example of an extruded plan form, which isn't very efficient. You have the house stretched out with a long extruded envelope. There's one wing here, north is to the right. There's one wing here, which has some good northern orientation, but the rest of it is primarily facing east and west. So all these windows are much harder to shade than if they were north facing. If this wing was perhaps running east-west with the garage in between, it might be a more efficient form. So windows are quite crucial, especially in terms of getting a higher rating. They're the weak point in our building envelope. We can insulate our walls at floors, or if our floor is a concrete slab on ground, or our roofs, we can heavily insulate. But glass, it's difficult to insulate. So it will be the point where we lose most of our heat or gain most of our heat. There's a range of different glazing options. Low E is low emissivity. That reduces the amount of heat that's sort of transmitted through the glass. So it can reduce heat coming in, which is good in summer. And it does also reduce heat flow out at night. It can be a cheaper option than having to go to double glazing, which is really the optimum. Double glazing being 2 sheets of glass with an air pocket in between. That air pocket is usually a vacuum. It can have an inert gas, such as argon. The main criteria for selecting windows are the U value, which is a measure of the heat transmittance. It is the inverse of the R value. Normally, insulation, we talk about R3 or R2 bats. The U value is the inverse of that. The next value, the SHGC, is the solar heat gain coefficient. So it's a measure of if the direct sunlight hits the glass, how much, and the window frame, how much of that heat is transmitted. There is a window rating scheme in Australia called the WERS rating scheme, and that will tell you the U value and the solar heat gain value for all the windows that have been rated. It also gives you a value for the light transmittance, which is worth keeping in mind. Some of the special glasses that might have a low solar heat gain coefficient end up being tinted and cut down your natural light. So it's just something to be aware of. So that's talking about glass. The window frames themselves also affect the thermal performance of the windows overall. Conventionally, we use aluminium. There's now available thermal break aluminium windows, which is basically the frame is split in two with an insulative isolator between the inner and outer frame, which slows down the heat transmittance. There's also steel windows, which are being used a bit more. Both of these products are metal, and metal are very good thermal conductors, so they are the lower performing of the different types of window frames. Timber is an older style, more conventional frame. It has a low conductance, so thermally it's a good frame to use. There are the issues with the use of timber. Where is it sourced from? Is it sustainably sourced, FSC? It also needs more maintenance over the life of the building. It has to be resealed or painted. And that has an environmental impact as well as a cost. There's also composite windows, and you can see the image down on the right-hand side. And this is a combination of an aluminium external frame and a timber internal frame. So you get the thermal benefit of the timber internally, and you get the maintenance longevity benefit of the aluminium externally. They do cost a bit more than your conventional aluminium windows, but there is a thermal benefit. Another type of window, which is becoming used a lot more, is UPVC, which is a plastic, and obviously there are environmental concerns about using plastics, but these windows do perform thermally very well. It's a technology that's been used in America and Europe for well over 60 years. And it's developed that well that these windows, not only thermally do the frames work very well, but the systems generally have very good sealing. So with these windows, such as UPVC, timber and composite, we get higher U value in terms of lower U value, which means we get lower heat transmittance. So the rating of windows are important in the NaTHERS rating scheme. And historically, it has been problematic. There has been a bit of a disconnect with the windows that are available within the NaTHERS software compared to what is available in the marketplace. And part of that is that the number and range of windows available is constantly changing. There's new glass products coming onto the market. Recently, improved procedures have been introduced, and the connection between the database in the software and what's available in the marketplace is getting closer and will improve more. Within the software, there are default windows, which are just your average standard windows, but you have an option to use custom window, which means you can go to the WERS website and select any window available and put that into your software, if that's the window you're going to use. In terms of climate response, the solar heat gain coefficient is probably critical. U value is important, and obviously the lower the U value, the better in most climates. But with solar heat gain coefficient, obviously the strategy is a lot different in a colder climate than in a tropical climate. In a colder climate, you want to get as much of that solar heat gain as possible, so a higher value is better. In tropical climates, a lower value is better, as long as you don't lower the visible light transmission. One thing that can overcome some of the problems in terms of rating of windows and selecting the right product is if you know where you're getting your windows from, if there's a particular supplier you're using, let your NaTHERS assessor know which supplier you're using, and they can use those suppliers' windows in the rating to make sure you get as accurate a rating as possible. As mentioned previously, shading is important. Your traditional eaves, verandas help to provide good shade, but they also provide, outdoor living areas and a good connection to the outdoors. Pergolas are important. Operable shading is becoming more important as a result of climate change. We're getting more 35, 40-degree days in the shoulder seasons. Prior to the heat wave in January that Rob mentioned, the previous hottest day was back in November. And quite regularly now in Sydney in October, November, we're getting 30, 35 plus days. Traditionally, an eve would have been designed for midsummer, for the summer solstice. But now we need to be able to pull out shading or pull down shading for those hot days when the eaves aren't big enough. If we make the eaves bigger to compensate for that, we then start to cut out our winter sun. So operable awnings, screens, external screens and blinds, also pergolas with deciduous plantings. There's a whole range of options. And the range of external operable blinds, operable roofs is expanding exponentially, or it has expanded exponentially over the last few years. They're not cheap, but there are some budget options in the market. The awning featured in this lower picture here cost $1,200. But it's got a good warranty and it does help to improve the thermal comfort internally. Trees, planting trees in the long term and placing them properly. Evergreen trees can go well in a southeast or southwestern corner, and in the northeast, northwest, or to the north. Ideally, we should be planting deciduous trees. Insulation is very important. There's a whole range of products, but the ideal is to maximize the R value. The form of construction can limit the amount of insulation that can go in. A conventional stud frame is only 90 mil thick. You can get an R2.5 high density bat, which will fit into that. Alternatively, you can go to, like shown in this top photograph, a foam product. That product is probably more like R3, R3.5 in the same depth. However, it's more expensive and it also is a foam product. So there's other environmental impacts in terms of using such products. Reflective foil and air spaces have been used traditionally in the past. Not so popular now because there's concerns about condensation. It still can be useful in tropical climates to keep the heat out of roofs, but you need to be aware of the condensation risks and make sure that that's managed properly. Usually ventilation may help. So the different bulk insulations available are the typical bats or either fiberglass, polyester or wool. The foam options are PIR, polyisocyanate, expanded polystyrene or extruded polystyrene. You can also use insulative materials such as straw bales, which is shown down on the bottom here, AAC, which is aerated autoclave concrete. Hebel is the trade name. It's like concrete that's been foamed and so has very fine air pockets in it. Condensation risk is an issue with the use of insulation and the placement of insulation. We haven't got time to go into that, but be aware of it. We did have a talk, I think, at our branch 18 months ago. That video is online of a person from ProClima who make breathable membranes. It may be worth having a look at that. The Australian Building Codes Board has produced a handbook on condensation risk, which is downloadable from their website, and that's a good reference. Thermal bridging is important in terms of getting a good thermal envelope. It's something traditionally hasn't been modelled well within the NaTHERS framework. That's being looked at, and it's hoped with the update in 2022 that there will be it will be better included in the ratings. So thermal bridging is where, particularly with steel frames, you have a steel frame connecting your outer layer of the wall and the inner layer of the wall, and the heat will transfer through that steel frame because there's no insulation separating that frame between the two layers. There are some requirements in the National Construction Code, but good detailing can avoid this as a problem. Thermal mass is important, especially in temperate and cooler climates. It acts as a heat sink in both seasons, and it can help to stabilize internal temperatures. It works most effectively if it's insulated from the exterior. Traditionally, we've built brick veneer walls where we put all of our brick on the outside. It's much more sensible to put the brick on the inside and put the insulation on the outside. The brick then will stay cooler, and as the interior warms up, the brick or your concrete slab will absorb heat out of the air and keep it cooler. Similarly, in winter, if we design our windows primarily along the north side, the sun will come in during the day and our slab and our walls will absorb that heat and re-radiate that heat at night. So there's a range of different materials. Rammed earth is very good. But again, ideally, it needs to be insulated from the exterior. Mud brick is also very good thermal mass. It may be possible to do some external walls without insulation, perhaps say on the northern side, but to get a high rating with these type of natural materials, you will need to look at using some insulation in part of the external walls. Stone, although more expensive, although you may have found stone on your property, also is very good in terms of thermal mass. Ventilation is important for cooling and removing heat, and it's a matter of placing windows in the right location to catch wind and create breeze paths through your rooms. Ideally, a room should have windows on two sides, opposite or adjacent sides, and it can be better, rather than having one big window, to have two small windows. Sometimes you might have a bedroom that's landlocked and only has one external wall, rather than traditionally we put one large window in the middle of that wall. Two smaller windows spaced apart can give you a bit of a breeze path, as well. It will also give you better light distribution into the room. The type of window will affect the amount of ventilation. Casement type windows, which are the type of window that hinges from the side like a door, or louver windows, provide the most ventilation for the opening. Stack effect ventilation is very effective. If you can have high level windows, especially around a stairwell, the air within these rooms will tend to rise as it heats and collect at the top here. If we can open these high level windows, that hot air will escape, and you can pull cooler air from lower down, from shaded areas. And you'll get a natural draft effect occurring, especially at night. There's a process called night purging, where if you can induce that sort of ventilation when the outside air is cooler than inside the house, then it enables your thermal mass, which has absorbed all that heat during the day, to cool down and be ready for the next day to start sucking up the heat again. Infiltration is important, and this is where all those gaps, which traditionally in Australia we've not been very good with. There's a section of the National Construction Code that covers this. It's not well understood. We should avoid ceiling penetrations, avoid using recessed downlights. If you do use downlights, you can put covers over them. If not, you have to keep the insulation away from the downlight, which creates a little chimney that the heat can get up through. There's other lighting options: pendant lights, track lights, spotlights. You go to this effort to create a nice, tightly insulated envelope, and then we cut lots of holes in it to put in downlights, and it's sort of counterintuitive. Providing good seals around doors and windows are important. Exhaust fans and making sure that they're fitted with dampeners, and so they can be sealed off when needed. Good lining junctions on where our plasterboards and our skirtings and our wall, floor and ceiling junctions. Again, traditionally, we've tended to use skirtings and cornices just to hide gaps. We should be sealing those gaps before we fix our skirtings and architraves. And that is a requirement in the building code, but unfortunately, it's not well understood or followed through. So talking about the actual thermal performance rating. So if you want to know more about the NaTHERS process, you can go to the NaTHERS website. I recommend you use an accredited assessor. Unfortunately, there's only 2 states that you require assessors to be accredited: New South Wales and the ACT. The other states have some sort of requirements, but it does mean in most states, anyone could do a rating. They've had no training. They're not subject to any scrutiny. An accredited assessor who will be a member of one of the accrediting organisations such as ABSA, HERA, or Design Matters, all are required to have professional indemnity insurance. They are audited on a regular basis, and they're required to do CPD. So if you use an accredited assessor, you're assured of getting a decent result. In terms of the campaign that Renew is running, I think it's important to keep in mind that we should be pushing for a national accreditation of all NaTHERS assessors so that we can have consistent ratings right across the country. When you engage an assessor, brief them properly. If you want to go for an 8 or 9-star rating, let them know that early in the piece, and they will know that's what you're aiming for. Normally, they will give you a checklist with all the materials, colours, what type of windows, where you're putting lights. So you need to think about all those things before you get your rating. However, you can engage the assessor early in the piece. Quite often, we're brought in late in the process when the design's already been locked down and there's little opportunity to influence how the design can be improved. Even if your designer has done a quick sketch, send it to your assessor and they can give you some feedback as to whether you've got the plan form right, the orientation right, whether there's too much glass. And that could save you a lot of time and heartache later. Final certification is normally done at, in New South Wales, the DA stage. In other states, it's more at the construction stage. But there may be need for later revisions. You might have selected a particular type of window. When you get to actually build, that's not available or it's too expensive and you might need to go for a different type of window. So ask your assessor early in the piece what the process is and whether there's additional fees for doing a later revision. They need to get correct information. They need details on what all the materials are, not just brick veneer. Are we using plasterboard inside? Are we using a breathable membrane or reflective foil? What colour are the walls? What colour are the roof? And your designer will be able to help you with this. It's helpful to get the survey information so they can model adjoining buildings and get the orientation correct. A window schedule is important so they can accurately model the windows, and floor finishes are important. If you relying on your concrete slab to provide thermal mass and then you cover it with carpet, you interfere with the thermal transfer of heat into that slab because the carpet is like an insulative layer. Similarly, if you place timber over a concrete slab. So it's important to consider floor finishes. As I've already mentioned, where exhaust fans are, whether they're sealed, how many downlights there are. Once the assessor sets up the model, then any of the above items can be easily changed. You can change your window from a casement window to a louver window to see if it makes that room cooler, or you can change it to double glazing, and I'll show you a bit more of this. So during the assessment, the assessor can generate feedback to you, which can give you a lot of information, which can help you refine and optimize your design. This is an output from a rating which shows the energy demand for the different zones, which is basically the different rooms in the house. The chart, part of the chart to the left is the heating demands in each of the rooms. So you can see this zone here is the one that's demanding the most heating. The next section is the cooling. So the blue zone here is obviously the one that's overheating. And to the right here, we have the combined heating and cooling load. So if we want to get our rating higher, we need to get these high points down. So instead of perhaps putting double glazing everywhere, we might just put double glazing in this particular room and perhaps this room. For this room, we might put in a ceiling fan, or we might put in an awning on the window. So in terms of those questions about how much extra cost, if you go through a targeted design process, you can target your where that cost is going, so you get the most bang for your buck. When going beyond compliance, I'll just quickly go through the rest. These are just some things to keep in mind. If you've done a rating and you're finding it's too cold, they're quite obvious things. You increase the insulation, add more north glazing. Perhaps you might need to reduce the thermal mass. It's too much thermal mass and you're not getting enough winter sun to warm it up. Similarly, in summer, cooling can help, changing the colours externally, using a low E glass, which has a low solar gain. And this is more information that you can get back from the assessor showing a performance within a particular room. These graphs show what the software has predicted in terms of the temperature range within a particular zone. The chart at the top shows what a rating might be in an existing home or in a poor performing house. You can get a temperature as low as 11 and as high as 34, 35. The bottom chart shows what we should be trying to get for a 7 or 8 plus star house, where our temperature range is between 17 to 28, which is sort of the ideal. So then we have minimum heating and cooling requirements. I'll just quickly show you some examples of 8-star houses, and they're not a new phenomenon. I started working nearly 12 years ago with a company, Australian Living, with Cameron Rosen. Cameron was on a mission to show that we should be building 8-star houses all the time. And he did a development in Rose Bay where the 4 houses shown here were all designed by different architects and all achieved an 8-star rating. Similarly, the house below is also achieved an 8+ rating with the architects were Collins and Turner. This house used UPVC doors and windows, which was quite unusual at that time. We have done a lot of work with the Narara Eco Village just north of Sydney, near Gosford. We helped them develop their building standards, and they set, as part of their building standards, a 7-star minimum. There was a lot of debate within the village as should it be 7.5 or 8 stars, but it was decided to keep it at 7 stars to try and make it affordable for people, but then encourage people to go beyond. And they've found that most people have gone beyond. There's also a requirement in the building standards to exceed the basics requirements in New South Wales for energy and water. Also, all houses are required to have a PV system, and within the village, there will be a mini grid. There's also requirements within the building standards to address health and amenity through things as in terms of ventilation, access, choice of materials, etc. Waste is also covered, and as well as material choices. And there's been many different solutions. Here is shown a 9-star straw panel home, quite a small, compact, affordable home. Next to it is an 8.8-star hempcrete home. This is a project we've been working on, which is actually 2 houses. It's a house and a granny flat on the same development, which both got close to an 8-star rating. There was a bit of a challenge with the site. The view was to the east, which is this large white wall on this side. We use thermal mats with internal bricks, you can see in the photo at the bottom, as well as slab on ground in the lower levels, and internal brick veneer, as well as some reverse brick veneer walls. Insulation, we just went with conventional R2.5 bats, an R4 in the roof, so that's not excessive. And we've used breathable membranes for condensation control. To optimize window performance, we went to UPVC double glazed. Most UPVC window suppliers will do double glazing as a standard, so you're not paying that much extra for it. In this instance, we've added additional shading with sun hoods. You can see here and here. And there's a pergola and a veranda in this shared courtyard area. And we've also utilised colour. So east and west facing walls have light colour. North facing walls, we have a darker colour so that they'll absorb the winter sun. But in summer, these walls are shaded and don't get direct sun. These green walls are actually a reverse brick veneer wall. So the brick behind the green absorbs that warmth in winter. And this plan just shows you the planned form where north is up the page. And so it's not the ideal northern orientation, but we were still able to get a reasonable performance. This is another house which is currently under construction. This is an 8.6 star rating. This is a much better orientation. This is all north facing, so lots of good north facing glass. We've got thermal mass in the form of slab on ground on the lower levels. Some reverse brick walls to the east and west. Internal soil brick walls to give more thermal mass, but there's some lightweight cladding in these instances. The insulation, again, is fairly conventional, R2.5 bats. We have used some straw panel walls, which give an R value of R4.1. This is a very good product coming from Viva Homes. We have just recently completed another design where we're able, using these panels, where we're able to get to a 9-star rating, except we're still resolving with the client whether they want to go to that level. We may settle on an 8.7 star rating at this point in time and just see where they get to during construction in terms of final material choices. So an R4, conventional bat in the roof, breathable membranes. In this instance, we've used composite windows and primarily single glazed. We've just targeted some double glazing where it was needed, where some of the rooms were a bit colder. We've got a pergola to the north for shading. We've got just conventional eaves. We've got a sun hood at this level. Nothing outstanding, but it gives us that control. For color, again, we've gone with the concept of these north-facing walls are dark colored and the east and west-facing walls are lighter colored to reflect more of the heat. And that gives you an idea of the plan of the house, and this is north is in this direction. Difficult sites, if you don't have great northern orientation, it's even more important to optimize the plan form and get an efficient envelope and optimize the window types. Again, you may need to pay a bit more for better performing windows. Creating sun traps, and this is an example of a courtyard that allows winter sun to come in to the rear. So north might be to the left, and you can still get good winter sun deep into the rear of the house. Colour, again, as I've shown, can be useful, and a high performing envelope. You know, using one option to consider is to go for a thicker stud, maybe a 150 timber stud, and then you can use up to an R4 bat in your walls. And mentioned previously, floor finishes can help in terms of getting the most out of your thermal mass. I mentioned Your Home. Your Home has a program called Design for Place, where they've developed some typical designs which are developed at 7 to 7.5 star level. And they've developed them for a whole range of different climate zones around Australia. They're there, available free for download. And with that, you can get a specification which will tell you what insulation and what type of glazing you would need for different climates. And it's a very useful program. And this is from Renew, and it's an example from the Sanctuary magazine of a house design that is taken one of the Design for Place typical designs and then just tweaked it a bit to suit the location, and then they've investigated different options to get up to an 8.2 star rating. People often say NaTHERS doesn't work in tropical situations. Here's some examples here. A good reference is Josh Byrne is behind he has a site, I'll give you the reference later, where he's promoting quite a few of these designs. And again, it's climatically appropriate. You can see this design up here has lots of openings for ventilation, lots of big wide eaves for shade. And again here, which is in the Pilbara, I guess you've got big wide verandas, lots of shading devices, just open spaces. And so it's designing appropriately for the climate. We can do a rating, but can we make sure that it actually gets built to the rating? One thing to do is when you get your NaTHERS certificate, is to make sure it's included in the building contract, so the builder knows he's got to meet the requirements of that certificate. Also ensure that the plans clearly specify the insulation, window performance values, and the other materials that are noted in that certificate, and to ensure that joints are properly sealed. And ensure that all of these items are properly priced before signing the contract, and avoid the builder substituting with, let's say, lower standard. Ask the builder whether he uses a specialist insulation installer. Often, just people on a job may not know how to properly install insulation. And you can see, here's an example, this photo at the bottom, huge gaps left. Double check the specification of windows before they're fabricated, and make sure you're going to get the right U value and SHGC value that's been nominated on your NaTHERS certificate. Make sure someone, and preferably your designer, inspects the insulation when it's installed or prior to being at line, to avoid this sort of issue down here. Consider doing a blower door test to check the air tightness of your building. Okay, I've gone way over time, but here's some references. ABSA is a accrediting organisation for assessors. It's worth visiting them if you want to find an assessor to work with. As mentioned, Your Home is a very good resource. Josh's house has some very good 10-star and high-performing star house ideas on there. Renew, as you're probably aware, runs Sustainable House Day. I think we're likely to provide a link where you can actually look at the videos from the houses from last year, and you'll find quite a few examples of high-performing houses in there. And you're probably aware that Renew publishes both Sanctuary and Renew magazines, and you'll see regular articles that cover this. And finally, I'm from Delisle Huntwood in Sydney, and thanks for listening to me.
Thanks, Graham. Very informative session, and we learned a lot of how to design higher rated homes, and it will be good later on for the future. Any of the audience would like to build their NaTHERS A-star homes. Now, moving on to Q&A, I noticed that we are running out a bit of time. So I have only selected 3 questions. I grouped them, some of the questions are similar, so I grouped them into groups. So I'm going to pick 3 questions if that's okay. The remaining questions we will be able to email that to you, Graham, or what will be able to answer them and email to our audience if that's okay. My first question, I saw there are a few people asking the same question, is about the affordability, about NaTHERS like A-star homes, and how we can make sure like these good rating homes can like beat the other properties in the market, because the cost affordability is really such a problem in major cities like Sydney and Melbourne. And what's your opinion on that, Rob?
Thanks. Yeah, it's a really good question, and I think there's 2 sides to it. One is a decision that you might be making as an individual home builder, and one is what it means for public policy and for the community at large. As an individual home builder, Renew's analysis has found pretty consistently that that building at a higher standard can pay for itself through reduced energy bills. So even if there is a higher upfront cost because of higher standard of building, the energy bills over the course of a mortgage can be substantially lower. And our analysis has found that often it's around about the 8-star level. So between 7.5 and 8-star level is kind of the peak payback point. Basically, it's where the value of a home is highest. Once you're getting up to the 9 and 10-star level, sometimes it can be more expensive to make those improvements, and the cost ratio changes. But nonetheless, the principle remains the same, that you might pay a bit more upfront, but you're saving money through energy bills over a longer period of time. And so, it's really important to have that context. In terms of what it means more broadly, if the national code is changed and the minimum standard is changed, past experience when we went from 5 to 6 stars shows that the costs that were expected by industry were actually much lower in reality than what was forecast. So the forecast was somewhere between 1% and 4% increase in the cost of building a home, and consistently it came in lower than what was predicted. By lifting the rules for everyone, it actually improves the rate at which industry learns how to do things. It improves industry learning rates. It can have the same effect as, for example, government investing in social housing at a really high standard that can improve industry's ability to build to this level. Finally, when it comes to first home buyers, it's just worth noting that while the developer or the builder might pay a higher price to some degree, perhaps a low degree, but perhaps to some degree, the purchase will still be made. The demand for homes and who you're competing against in a mortgage in most cases, or in purchasing a home, actually has a really big bearing on the cost. And so, if anything, it's the biggest builders who would be bearing more of that cost to the benefit of those first home buyers. So, I think that in the end, it's actually to the benefit of people, particularly people on lower incomes and people who are first-time buyers. Generally, will win out from this.
Yeah, because in Graham's talk, he did mention that the upgrade of 7-star homes will be cost neutral. So that would be a good example of that. And moving on to the next question.
Sorry,
Graham, would you like to jump in?
Yeah, just a couple of points. There are some loan providers who will actually give you a better interest rate if you have a high performing home. So over the life of a mortgage, you know, a 1% difference in your mortgage rate, you know, may go a long way to making the saving. But also you have to keep in mind it's not just reduced energy bills, it's a much more comfortable environment you'll be living in. And that's something that it's hard to put a cost on.
Yeah, definitely. We don't want to be freeze to death in winter, like being too hot in summer as well. So the next question I got to see a number of people ask is the strategy of reducing the cost of double glazing. Would that be like more achievable if we add shutters to the single glazing instead of like doing the double glazing? I think it's a question to you, Graham.
Yeah. Look, shutters can help, but they only, they end up cutting out the light. And I would recommend, if you really want good performance, you want to think about window furnishings as well as having a good quality window. So I would recommend, if you can afford it, double glazing is the better way to go. And following on from what Rob just said, if we raise the bar to 7-star, there'll be more demand for double glazing. They will be making more. It will become cheaper. And it has become cheaper over the last 20 years. And especially with say, the UPVC manufacturers, you know, they're quite cost competitive now with aluminium framing, and they're providing double glazing as the standard. One of the challenges is some of the regional areas aren't well serviced. And that's something, I guess, that maybe could change. If there's an increase in demand, then, you know, people will maybe in regional areas be able to access a better range of products. But traditionally, windows have improved in the last 20 years in their performance, but also the cost of special glazings have come down. And it's very rare now that people will just install single glass. You know, it's usually either a special glass, low E, or double glazing.
Yeah, let's really hope that the construction code will get upgraded really soon. Maybe that would be our last question. A few people also ask, how should we insulate concrete slab?
Well, it's a matter, I think the first question is, should you insulate a concrete slab? It depends what climate you're in. If you're in somewhere like Canberra or Southern Australia, it makes sense to insulate a concrete slab. Traditionally, in more temperate climates such as Sydney, you might consider doing it. But what you need to keep in mind is, if we're going into a warming climate, if you've insulated your slab, it holds heat in. And so, although it improves the winter situation, especially if we're concentrating, say, on Sydney, our winters are likely to become milder and our summers hotter. I would not advise insulating, certainly under the slab. Some edge insulation can be effective, but you also have to be careful that you don't compromise your termite protection. So just something to be wary of.
Great answer. I think we ran out of time tonight. But
Okay.
we would probably email to, for all the questions we haven't answered in Q&A, we will be able to email that to you, if that's okay with Rob and Graham.
Yeah, sure.
We get a copy of the questions and then we'll email to Rob and Graham, and then we will email to our audience. All right, thank you everyone. I would like to thank our two speakers, Rob and Graham, and I hope you all found it very informative. It seems like we can go to another section about how to design a NaTHERS house and showcase some of the examples as just what Graham showed us tonight. So the recording of the webinar will go online in the next few days, and we will be probably able to send you the link later on as well. So thank you everyone. Thanks Graham, and thank you Rob.